Laws of logarithms. We're going to go over several logarithm properties and just learn how to use them. And these laws of logarithms apply to whether it's log log or natural log. Number one is that the log base a of a times b equals log base a of a plus log base a of b. Basically, if you have multiplication, it can split into addition, or you can go the other way around. If you have addition, you can squish it all back together into multiplication. Number two, log base a of a over b equals log base a of a minus log base a of b. If you have division, it splits into subtraction. The other way around, if you start with subtraction and you need to condense it, you can put it back into division. Number three is especially useful when solving equations. It says log base a of a to the power of c equals c times log base a of a. And that is saying that if you have the log of something with an exponent, you can move the exponent to the front. Now, when we're dealing with logarithms involving radicals, the radicals need to be converted to fractional exponents. So let's remember these exponent rules. You can go from radical to exponent form by putting the little number outside of the radical on top of a fraction. The exponent inside goes on the bottom. Especially remember that when you apply that to square root of x, you end up with x to the 1/2 power. So when we're working with logarithms, we never leave things in radical form. We always convert to fractional exponents. So this says evaluate the expression. We see that we have addition here, so we can combine those into multiplication. That would be the same thing as log of 4 times 25, which is 100. Now, if you remember from a previous lesson that if you don't see any base at all, there's an understood 10. And we can rewrite this as log base 10 of 10 squared. And then the property from the previous lesson says if the base and this number are the same, it all just sort of cancels and you end up with the exponent as the answer. For the next one, log base 3 of 1 over the square root of 27. We don't want to leave radicals, so that would be log base 3 of 1 over 27 to the 1/2. It's still hard to deal with because the 27 is on the bottom of a fraction. Still applying exponent rules, we can flip that 27 up to the top if we make our exponent negative. Now it becomes like the previous problem. I can get my base and my big number the same if I change 27 to 3 cubed. And that's all still to the negative 1/2. Another exponent rule is when you have an exponent outside the parentheses, you multiply the exponents. So it becomes log base 3 of 3 to the negative 3/2. 3 times negative 1/2. Now I've got the 2 3's, that all just goes away, and the exponent is my answer, negative 3/2. Now we have subtraction. So we can combine those back together as division. It would be log base 4 of 192 divided by 3, which is log base 4 of 64. And then we can convert the 64. Log base 4 of 4 to the 3rd power. All that 4 and log goes away, and you're just left with the exponent. Now we're going to practice expanding and condensing these log forms using our rules from this lesson. Use the law of logarithms to expand. So we can see that we have multiplication. That splits into addition. Log of x to the 5th plus log of y to the 6th. That was law number 1. Now law number 3 says if you have exponents, you can move them to the front. So that becomes 5 log x plus 6 log y, and now it's expanded. That's as far as you can go with that. Log of the cube root of x over y cubed. We don't want to leave the cube root like that, so we're going to write that as log of x to the 1/3 over y cubed. We have division, which splits out into subtraction. log of x to the 1/3 minus log of y cubed, and then our exponents can move to the front. 1/3 log x minus 3 log y. The next one, we have a variety of division and subtraction. In general, if you're pulling something from the top of the fraction, it should be positive or have a plus in front of it. If you're pulling something from the bottom of the fraction, it should have a minus in front of it. So when I split all this apart, it's going to be log base 2, and it's positive because we're getting this x cubed from the top, and then a plus because y to the 4th is on the top, but the z is on the bottom, so we'll do minus log base 2 of z to the 6th. So everything that comes from the top should be positive, everything that comes from the bottom should be negative. Now move your exponents to the front. And then it's all expanded. This next one is similar, only we have two variables on the bottom and just one on top. So both of the ones on the bottom will need to be minus. Log base 2 of x cubed minus log base 2 of y to the 4th minus log base 2 of z to the 6th. Again, exponents to the front, and then it's expanded. Now we're going to go the other way around. We're going to start with expressions that are expanded. We're going to kind of squish them all back together. So the first one is 5 natural log x plus 2 natural log y. So completely reversing the order of everything we were doing previously, we need to put the exponents back first thing. Natural log of x to the 5th plus natural log of y squared. Now it's addition. Addition goes with multiplication, so finally we would have natural log of x to the 5th times y squared. This next one we have minuses and positives, so first put the exponents back on. Log of a to the 6th minus log of b cubed plus log of c to the 7th. Anything with a minus in front of it needs to be on the bottom of a fraction. If it's positive in front, it needs to be on the top. So we would have log of, the positive ones are a to the 6th, c to the 7th, and the negative one, which goes with division, is b to the 3rd. Now this last one is a bit messy. There's more than one correct order to do things here, but I'm going to distribute this 5 in front of all the logs. And I'm also going to change the square root of 7 to 7 to the 1/2 power. So we've got 5 log of x minus 3 plus 5 log of 7 to the 1/2 minus 5 log of x plus 6 cubed. Now the 5's in front become exponents. If there's already an exponent, you're going to multiply it. Log of x minus 3 to the 5th plus log of 7 to the 5/2 minus log of x plus 6 to the 15th. Now, condensing it all together, positive things go on top of the fraction, negative on the bottom. Log of x minus 3 to the 5th times 7 to the 5/2 over x plus 6 to the 15th. This last little bit has to do with putting logs into the calculator, and we said in the last lesson that the log button on the calculator is the log that's base 10. But what if you need to use your calculator to find a log that's not base 10? That's when you use the change of base formula. So log base b of a equals log a over log b. The base goes on the bottom. B for base, B for bottom. I need to evaluate log base 7 of 13. So using the change of base formula, that goes log 13 over log 7, and then just punch that in your calculator, round to 4 places, 1.3181.